A 10 kilogram projectile is launched from ground level at an angle of 60 degrees above the horizontal with an initial speed of 12 meters per second. The horizontal component of its velocity is to the right. So let's draw this. We have 12 there. So we'll have 12 cos 60 horizontally, and then 12 sine 60 vertically. And then this is 60 degrees to the horizontal. At the point during its flight when the vertical component of its velocity is 0, so immediately we should identify that as when it's at the maximum height, and it would just have a horizontal component, 12 cos 60 degrees. The projectile splits into two pieces, P and Q, each of mass 5 kilograms. Immediately after the projectile splits, piece P has velocity 14 meters per second to the right. What is the speed of piece Q immediately before it hits the ground? Well, we know that Q will have two components, the vertical and horizontal. The horizontal one will be the same as when it broke away from this projectile, so when it split into P and Q. So if we find that out through conservation of momentum, we can get this component. So if we write that down, we have 10 times 12 cos 60 is the initial momentum, so 12 times a half. This gives the initial momentum of the projectile, and this will equal the momentum of P, 5 times 14, and then minus the momentum of Q, so 5 VQ, assuming Q is going in this direction. So if we rearrange this, we get 5 VQ equals 5 times 14 minus 10 times 6, so 70 minus 60, which is 10, which means that VQ is 2 meters per second. So now the issue is, how do we get the vertical component as it approaches the ground? Well, if we notice, the projectile went up to a maximum height, split off, and then Q is going to go back down to the ground. So whatever vertical component the projectile lost as it went to this maximum height, Q is going to gain that vertical component back. You can see this with the kinetic energy, half m v squared equals mgh. You can see here that v squared is proportional to h. So if you had an initial kinetic energy, this will dictate what maximum height you can get to. And if you start at a certain height, this will dictate what velocity you get once you reach the ground. And these will be the same. So that means Q will have a vertical component going down of 12 sine 60, the same as what the projectile had as it was going up. So we have 2, and then we have 12 sine 60. So we just need to do a bit of Pythagoras here. Converting sine 60 as root 3 over 2, we have this as 6 root 3. And then we're going to need to square both of these and add them together. So it's best to take out a factor of 2 first, and then square the 1, and then the 3 root 3. So I've just said that this is a triangle of 1 and 3 root 3 scaled by 2, because taking out factors in the NSAA will save you a lot of arithmetic and algebra that you don't really have time for. So if we put this in, we get 2 root of 1 plus 3 squared is 9, times 3 is 27, which is 2 root 28. And then 28 is 4 times 7, so we have 2 times root 4 times root 7, which gives us 4 times root 7 meters per second. So we can identify this as answer D. So it has a speed of 4 root 7 immediately before it hits the ground.